Hi, I'm the wannabe coder, and welcome back to the Pac-Man and Python series. This is episode 7, and in this one, we're adding the first real challenge to the game, the enemies. So far, we've built the maze, let Pac-Man move through it, collect pellets and power pellets, and even track score and lives with a user interface. But now, it's time to introduce the ghosts. In this episode, we'll create a new class for our enemies, spawn them into the maze, and give them some basic movement so they can roam around. It won't be full AI behavior just yet, but we'll lay the groundwork for smarter ghosts in the next episode. Let's get started. But first, let's do a quick recap of what we covered in the last episode. We made the game feel much more interactive by letting Pac-Man collect pellets and power pellets as he moves through the maze. Each regular pellet adds 2 points to the score, and each power pellet gives a big boost, 50 points. We also added a temporary speed boost whenever Pac-Man eats a power pellet, and made sure it resets after a few seconds using a new method called reset speed. On top of that, we created a simple user interface at the top of the screen, showing the player's score and how many lives they have left. So now we've got movement, collision, scoring, and feedback, but no real threat. Let's change that by adding our enemies. Alright, now let's switch over to our constants.py file and add 2 new parameters that we'll use for the enemies. The first one is enemy_number equals 7. This defines how many enemies we want to spawn in the maze. I think 7 is a good place to start. It creates some tension, but still gives Pac-Man enough space to move around. Next, let's define how fast the enemies move. Enemy_move_speed equals 5. This works just like the player's movement speed. Later on, we can adjust this number to balance the difficulty, or even make the enemies faster as the game progresses. With those constants set, we're ready to start building the enemy class. So let's switch over to our actors.py file and start writing the code that brings our ghosts to life. At the top of the file, in the import line where we bring in values from constants.py, we add one of the parameters we defined earlier. We write enemy_move_speed. This gives our enemies access to their movement speed and lets us control how fast they move through the maze. Then, we'll import the random module. This will help us later when the enemy hits a wall, so we can randomly choose which direction it should go next. Now, let's scroll down and create our new class. Class enemy, open parenthesis, actor, close parenthesis, colon. This class is very similar to the player class, so we can actually copy most of that code and just tweak a few things. But compared to the player class, the enemy class takes 3 parameters in its init method. Start_x. This is the starting X position where we want to place the enemy on screen. Start_y, same idea, but for the Y position. Walls, the full list of wall coordinates, so the enemy can detect and react to wall collisions. Now back to the class itself. Inside the init method, we make some important changes. First, we set the enemy's fill color to red, just to make it visually different from Pac-Man for now. Later on, we'll swap this out for a custom ghost shape. Next, we need to make sure our enemy spawns at the right place. We add self.goTo, open parenthesis, start_x, comma, start_y, close parenthesis. This moves the enemy to the X and Y coordinates we passed in, so it starts in the correct position inside the maze. Then, we set the enemy's state to move, so that it's active as soon as the game begins. Since enemies don't need a score or lives, we delete these lines. We also remove self.move_speed, because in this version of the game, enemy speed is constant. Now, let's add movement. We scroll up to the move method inside the player class, copy it, and paste it into the enemy class. The only thing we need to change is the movement speed. So inside the self.forward we replace player_move_speed with enemy_move_speed. That's it. The movement logic stays exactly the same. Next, we do the same thing for wall collision. We copy the check wall collision method from the player class and paste it into the enemy class. But here, we make one key change. In the original method, when the player hit a wall, we wrote self.state equals stop. But for enemies, that wouldn't make sense because we don't control them directly. So instead, we delete that line and replace it with self.start_move with parentheses. This calls a new method that we're about to define, one that picks a new direction the enemy can move in. And make sure to do this in every place where self.state equals stop appears inside the collision logic. We want the enemy to keep moving, not stop, no matter which direction it hits a wall from. So now, let's go ahead and write that method. We start with defining the method by writing def start_move, open parenthesis, self, close parenthesis, colon. This function is called whenever an enemy hits a wall. Since the enemy can't keep going in the same direction, we need to figure out where it can go next. So here's the idea. We check all 4 directions around the enemy, up, down, left, and right, and see which ones are not blocked by walls. Then, we pick one of the open directions at random and turn the enemy to face that way. That's it. It's a simple way to make the enemy keep moving and avoid getting stuck. Now let's break it down, one line at a time. We start by calculating the coordinates of the 4 adjacent cells, the tiles to the right, left, top, and bottom of the enemy's current position. We write right_cell equals round, open parenthesis, self.x, core, open and close parentheses, plus cell_size, comma, round, open parenthesis, self.y, core, open and close parentheses, close parenthesis. This gives us the coordinates of the tile directly to the right of the enemy. Next line, left_cell equals round, open parenthesis, self.x, core, open and close parentheses, minus, cell_size, comma, round, open parenthesis, self.y, core, open and close parentheses, close parenthesis. This gives us the tile directly to the left. Then we write top_cell equals round, open parenthesis, self.x, core, open and close parentheses, comma, round, open parenthesis, self.y, core, open and close, parentheses, close parenthesis, plus cell_size. This gives us the tile directly above. And bottom_cell equals round, open parenthesis, self.x, core, open and close parentheses, comma, round, open parenthesis, self.y, core, open and close parentheses, minus cell_size. That gives us the tile directly below. Finally, we create a list of all directions. Next underscore, possible. Cell equals open bracket, right_cell, comma, left_cell, comma, top_cell, comma, bottom_cell, close bracket. This list contains all the directions the enemy might be able to move toward. In the next step, we'll filter out any tiles that are blocked by walls. Now that we have the 4 possible directions stored in a list, let's filter out any directions that are blocked by walls. We write, for cell in next_possible_cell, open bracket, colon, close bracket, colon. That's a loop. It means go through each cell in the list of possible directions. But pay close attention to that part. Open bracket, colon, close bracket. This is called list slicing, and in this case, it creates a copy of the original list. Why do we need a copy? Because we're going to remove items from the original list while we're looping through it. And if you try to change a list while looping directly over it, Python can behave unpredictably. It might skip over items or give you errors, So instead, we loop through a copy and modify the original safely. Inside the loop, we write, if cell in self.walls, : This checks if the current cell is in the list of walls, meaning it's a wall tile, and the enemy can't move there. If it is, we write, next underscore possible underscore cell dot remove, open parenthesis, cell, close parenthesis. This removes that cell from the list of possible directions. So by the end of the loop, next possible cell contains only the directions that are not blocked by walls. Now we randomly pick one of the remaining options. Next underscore cell equals random.choice, open parenthesis, next underscore possible underscore cell, close parenthesis. This selects one valid direction from the list. Next, we figure out which direction was chosen and rotate the enemy to face that way. We write, if next underscore cell equals right underscore cell : self.set heading, open parenthesis, 0, close parenthesis. This means if the next cell is to the right, face right, which is heading 0 degrees. We do the same check for the other directions. L if next underscore. Cell equals left underscore cell : set heading to 180. L if it equals top underscore cell : set heading to 90. L if it equals bottom underscore cell : set heading to 270. Finally, we write self.state equals quote move quote. This ensures the enemy starts moving in the new direction we chose. And just a note, this line is important because later in the series, we'll tweak the game so it doesn't start running immediately as soon as we launch the file. Setting the state here ensures the enemy keeps moving when it's supposed to. And that's it. Now, whenever the enemy hits a wall, they'll check all directions, filter out the blocked ones, and randomly pick a valid path to continue moving. Now, let's go back to main.py and create our enemies. At the top of the file, we start by importing the constant we defined earlier, enemy_number. This tells the game how many enemies we want to spawn. So, we add to the import from constants line, enemy_number. Next, we also need to import the enemy class itself, so we can actually create enemy objects. In the line where we import from actors.py, we add enemy. Now we're all set to start generating enemies inside the maze, so let's scroll down to our main function and create the enemies. We'll do this just below the line where we created the player instance. Let's go through it, step by step. We start by writing enemies equals open bracket, close bracket. This creates an empty list that we'll use to store all our enemies. Next line, for underscore in range, open parenthesis, enemy_number, close parenthesis, : This is a loop. It repeats as many times as the number of enemies we want to create. We're looping through numbers here, like 0, 1, 2, and so on. But since we don't actually need to use the number itself, we use an underscore as the loop variable. This is a Python convention. Inside the loop, we write enemy_start_x, enemy_start_y equals random.choice, open parenthesis, pellets, close parenthesis. But first, we need to define it above by writing pellets equals pellet_pen.pellets. This line picks a random starting position for the enemy. We use random.choice to choose one pair of coordinates from the pellets list. We store the x and y values in two variables, enemy_start_x and enemy_start_y. This way, each enemy will start somewhere inside the maze on a valid, walkable tile. Next line, enemy equals enemy, open parenthesis, enemy_start_x, enemy_start_y, walls, close parenthesis. This creates a new enemy object using the enemy class. We pass in 3 arguments, the x and y coordinates and the list of walls, so the enemy can detect wall collisions. And finally, we write enemies.append, open parenthesis, enemy, close parenthesis. This adds the new enemy we just created into the enemies list. The loop repeats this whole process, so we end up with a full list of enemies, each one starting at a different random pellet location in the maze. And that's it. We've now created our enemy characters and placed them inside the game world. Next, we'll make sure they actually move. To do that, we pass the enemies list into the game loop function. This lets the loop keep track of the enemies and update them every frame, just like we do with the player. So we scroll down to the line where we call the game loop, and we add enemies at the very end of the argument list. Now the game loop has everything it needs to control player movement, UI updates, pellet logic, and now enemy movement too. Now let's scroll up to the game loop function itself and update it so the enemies actually move. First, we need to add the enemies list as a parameter to the function. At the top of the game loop definition, at the end of the parameter list, we add the enemies list. This gives the function access to the list of enemies that we created earlier in main.py. Now, let's get them moving. Inside the game loop, right below where the player's movement is handled, we'll add a loop to update each enemy. We write, for enemy and enemies, enemy.move, open and close, parentheses, and then enemy.check_wall_collision, open and close parentheses. This goes through each enemy in the list, moves it forward, and checks for wall collisions, just like we did with the player. Now, there's one last thing we need to update to make sure the enemies keep moving. Not just once, but every frame. We scroll down to the end of the game loop function and look for the line that schedules the next frame with onTimer. Inside that lambda, we need to make sure the enemies list is also passed in every time the game loop repeats. So we update the line to include it at the end. Now the game loop will receive the enemies list on every frame, so the enemies can keep moving continuously as the game runs. That's it. Now the enemies are active, they're moving through the maze, and automatically picking new directions when they hit a wall. All right, now go ahead and run the file. Here's what you should see. 7 red circles. Those are our enemies, spawning at random positions inside the maze. They'll immediately start moving on their own, and whenever one of them hits a wall, it will automatically choose a new direction. They'll keep doing this throughout the maze, moving forward until they hit a wall, then turning and continuing in a new path. Now here's something important to note. Enemies only change direction when they hit a wall. If they pass by an open intersection, they won't make any turns. That's totally fine for now, but we'll tweak that behavior later, so they can actually chase Pac-Man instead of just wandering around. And right now, even if an enemy passes straight through the player, nothing happens. So let's change that. To make that happen, let's return to the game loop function and add the logic that checks for collisions between enemies and Pac-Man. Inside the loop where we move and check wall collisions for enemies, we add this line. If enemy.distance, open parenthesis, player, close parenthesis, less than, cell_size divided by 2, colon. This checks whether the enemy is close enough to touch Pac-Man. If the distance between them is less than half a tile, we treat it as a collision. Inside that block, we write player.goto, open parenthesis, random.choice, open parenthesis, pellet_pen.pellets, close both parentheses. This teleports the player to a random pellet location on the map. Then, we reduce the player's lives by writing player.lives minus equals 1. So now, every time an enemy catches the player, he loses 1 life and gets reset to a new position on the map. Let's test it out. Try getting hit by an enemy and watch what happens. Now, everything is the same as before, except when an enemy catches Pac-Man, he's immediately moved to a different tile, and you'll see he loses 1 life, as shown in the UI at the top of the screen. We can now play the game because it finally feels challenging. All right, Let's do a quick recap of what we built in this episode. We created a brand new enemy class, gave it random starting positions, and added logic so the enemies move through the maze and change direction when they hit a wall. Then we placed them inside the game, passed them into the game loop, and added collision detection so that every time an enemy touches Pac-Man, he gets sent to a new tile and loses 1 life. And just like that, we've taken our game from calm and quiet to something that actually feels challenging. In the next episode, we'll take things a big step forward. By giving our enemies some basic intelligence, we'll make them actually chase Pac-Man based on his position, which means you'll have to stay sharp and keep moving. We'll also start improving the game flow. Right now, the game starts as soon as the window opens, which can feel a bit sudden. So we'll add a short delay at the beginning to give you time to get ready. And when the game ends, whether you lose all your lives or manage to eat every last pellet, we'll display a message and gracefully close the game window. These little touches are what really make the game feel complete. If you found this helpful, a like and subscribe would really help support the channel, and make sure you don't miss what's coming next. I'm the Wannabe Coder. Thanks for watching, and I'll see you in the next episode.